All right, so we're on problem number D that says an initial population of 300 bacteria doubles in size every 3 hours. Estimate the bacteria population after 10 hours. So we're going to make a little table again, and we're going to look at the hours and the bacteria, right? So at 0 hours, the bacteria is 300 bacteria, right? And then it doubles every 3 hours. So we skip how many are at 1 hour and 2 hours, but at 3 hours, it's 300 times 2, right? And then skip 4 and skip 5 and skip 6. I mean, there's bacteria there, but we don't know how many. But at 6 hours, it's 300 times 2, and then times 2 again, right? Because it doubled, right? And then 7 hours and 8 hours and 9 hours. And at 9 hours, it's 300 times 2 times 2 times another 2. Okay? So notice the exponent is, we're adding an extra factor of 2 every 3 hours. And so if I were to write a formula for the number of bacteria, let's call it bacteria of whatever, what are we doing? Hours, T, is 300 times, notice there's a 300 all the time, times 2 to what power? Well, at 3 hours, so it's T hours, right? But it's not every hour that it doubles, it's only every 3 hours. So how do we say that the exponent increases every 3 hours? We'll just divide the number of T by 3, right? So at 3, it's 2 to the first. At 6, it's 2 to the second, which would be 6 over 3. And at 9, it'd be 2 to the third, which is 9 over 3. Okay, so there's our formula for finding the number of bacteria. So now we can find them in 10 hours. Notice 10 hours is the next hour after 9, and we wouldn't know how many there are. But our formula is going to let us find that. So that'll be your job to do that. So in class, we will find B of 10, which is the number of bacteria after 10 hours. All right, let's look at E. And E is the number that's approximately 0.271828. And that was discovered kind of the same way that pi was discovered. Okay, so how do we use E? Well, our calculator has an E button. Let me show you mine. So there's my e to the x button. Let's see, I don't know if you can see it. It's e to the x. There it is right there. So when I want to punch in, let's say, e to the second, on my calculator, I have to type in the 2 first, and then e to the x, e to the second is going to be punching the e to the x button. You can almost see it there. And that's e to the second power. Okay? Or any power. Let's say I want to find e to the 2.6 power. 2.6, and then e to the, and that's e to the 2.6. Whatever e to the 2.6 means, right? All right, so that's how you do that. So if I was going to use this formula and find f of negative 4.1, on this one, f of negative 4.1, notice that's just x, right? X is negative 4.1, be negative 3.8 e to the 0.435 times negative 4.1. Okay. Notice you might want to multiply that first, and then do e to that power, and then times that, and we'll finish that off also in class. Okay. And we'll round to 4 decimal places if necessary. All right. So this just goes through how do we derive our formula for continuous compounding and compounding a certain number of times. So I don't know that I want to go over that. I would want to say that when you're compounding, you're just taking this to an extreme, and when you take it to an extreme, it actually equals E. Okay? When you take that to an extreme, just that part, the 1 plus r over n to the nt power. That means that you make these smaller and smaller, or there's more of them in 1 year. Okay? All right. So this is what we want to know. How do we use those formulas? Okay? Or what formulas are they? All right. So do we have, okay. So we have principal P dollars. That means an investment or a loan. Deposit and account paying an annual interest rate of R. in decimal form, compounded n times per year. So quarterly would be 4 times per year, and monthly would be 12 times per year, right? So n equals 4 for quarterly, n equals 12 for monthly. Then after t years, the account will have that much money, right? A equals whatever we get from multiplying the initial amount times all this stuff right there. All right. Actually, we can do it this way. It looks a lot nicer. Yeah, that way right there. Okay, so that's our formula. And then for continuous compounding, that turns into e to the RT, right? So that's for continuous compounding, right? The money in an account is the initial amount e to the RT, which is the interest rate times the number of years. All right. So find the final value of each amount. So we're just going to set these up and then we'll work them out in class. All right. So the first one is compounded quarterly for 8 years. So quarterly means n equals 4. And that means we're going to use A equals P times 1 plus R over N to the NT power. All right. So that means we need to know what R is, and R is 0.08. We need to know what n is, n equals 4, and we need to know what t is, and t equals 8. Okay? What is A? We need to know what A is. Oh, we don't know. That's what we're going to figure out. What is P? Well, that's the initial amount, right? $2,000. All right? And we have everything we need to find A. All right? So we'll finish that. You know what? Let's work this one. Let's set it up a little bit better. So A is going to be 2,000. Times 1 plus 0.08 over 4, right? That's R over N, to the N, 4 times the number of years, 8. Okay? And notice you might want to simplify that, right? 1 plus 0.08 over 4, you can do the division, add it to the 1, and then finish that off. Okay, so let's set up the second one. So the second one, 2088% compounded continuously. So we want to just, you know what, let's leave that one for class. We'll leave that one for class. Let's finish this one up here. All right, so this will be A equals, and I'm just going to simplify a little bit. So 0.08 divided by 4 is 0.02, plus 1 is 1.02. So this is 2,000 times 1.02 to the 4 times 8 is 32. Okay, so I'm going to do the 1.02 to the 32nd power. And if you notice, you need to use a scientific calculator, and you need to have a y to the x button. Okay, so mine, to test your y to the x, by the way, to know which number to punch in first, do a number that you know what the answer should be, like 2 to the third is 8. So I'm going to type in 2, and on my calculator I say enter. To the third power is 8. There you go. So on my calculator, I type in the 2, the base, and then the power. Okay, so this one then, I should type in the 1.02 to the 32nd power is 1.88454, etc. And then times 2,000. Times is 3,769, about 3,769.08. Okay, all right. So for this one, don't forget to find A equals PE to the RT. That means you'll need to know P, you'll need to know R, and you'll need to know T. Okay, all right. And let's finish off with transformations. So transformations work the way they've worked before, right? When you have let's just do an example, right? So we'll do this first example here. We're going to graph that, and then this one we'll graph it over here. All right, so we'll graph the first one together. So we're given the graph of f of x equals 2 to the x. So y equals 2 to the minus x plus 1. Remember, the plus 1 means we're going to shift up 1. And the 2 to the minus x, when the minus is on the x, which is in the argument, that means we're gonna do a reflection, but horizontal. That means left to right, right to left. That means all these points are gonna go this way, and all these points are gonna come this way. Okay, all right. But we're gonna shift also up 1. So I'm gonna just note my shift up 1 there, and then these points are going to come this way, And then these points are going to go that way, right? So there, and then there, and then this one is up at the 9 over here. Okay, so, oops, I'm not showing what I'm doing. All right, so these points got reflected over here, and these points got reflected over there, but shifted one up from the x-axis. Okay, so I'm going to connect them. Okay, so notice it's a horizontal reflection and a vertical shift, right? Horizontal reflection. Okay, horizontal reflection, right? So these points move over here, and these points moved over here, and it got shifted up one. Okay, and you're going to do this one. G of x equals 2 to the x minus 2 power. Notice that the minus 2 is being subtracted from the x, or it's in the exponent. Okay? All right. And I think that's the end of our section. Indeed it is. So that'll be the last thing we do in class. All right. That's the end of section 5.3.